welcome back to another OpenGL tutorial, and in this tutorial I want to talk about the vertex arrays and the vertex buffer objects, which are kind of similar. That's why I put they into the same tutorial. Okay, so now I have drawn out a simple triangle with immediate mode, and that's what we will replace with vertex buffer objects. So now if I run the program, as you can see, here is the triangle. I can move the camera because I included as always, and yes, that's pretty much it. So first of all, let me talk about the vertex arrays. So vertex array is basically an array where you store the vertices and or other stuff like the colors, and you can store the texture coordinates, the normal vectors, so on. So you can store everything in an array. So let me create an array like that. So I create a float array, call it f, and I just put all of the vertex coordinates into this array. So like that, this was the vertex coordinate of the first vertex, then next is the second vertex, and third is the first vertex. Now I have a vertex array. I just put everything into an array. Actually, this should be an array like that. Okay, so now let me try to render that with the functions for vertex arrays. To render that, let me just delete this immediate mode rendering and use GL enable client state. And you have to enable everything you want to use, like vertex array, color array, texture array, so on. And to enable that, just use the GL enable client state. It's not GL enable like we usually do. It's the GL enable client state because in theory it is stored in your own computer, not in the video card. So that's what the difference. There is not too much. Basically, this is just the GL enable. So GL vertex array. Right, and this was all. So let me just disable GL disable client state, and let me just disable the vertex array after the rendering. So here we will do the rendering itself. To do the rendering, you use the function GL vertex pointer. So GL vertex pointer. This is a function which basically points to a vertex array. There are a function called GL color pointer, there are another function called GL normal pointer, there are another called GL texture chord, text chord pointer, something like that. And this actually weighs 4 parameters. The first is how many elements does a vertex have. You know, we have the GL vertex 2f, GL vertex 3f, and GL vertex 4f, so you can have 2, 3, or 4 elements. I have 3 in this case because every vertex is actually 3 elements. The second parameter is the type. I use float, so I use the GL float enumeration values as the second parameter. Most of the times you will use floating point number to represent positions in space, but of course you can put other types in here like GL integer. Okay, or GL int, maybe, I'm not sure about that. Okay, the next parameter is actually the something called stride, and this basically tells that from that how many vertices, so how much byte data there are actually in between two vertices. In this case, there are 0 byte of data because after one vertex there is another vertex immediately, and after that vertex immediately the next vertex following. So you can just pass 0. I will show something called interleaved array in a moment. So we will write the color value into here into the array, and then the stride value will be changed. And the last value is actually the starting point, so basically a pointer to the array. So I just use the end f, so get the address of the f, actually just f, or get the address of f0. So this is basically where should it start. Then that was it basically. Now we need to just draw it. So now we tell basically OpenGL where is the data. We tell that we want to use the data. So the last thing to do is to actually draw it. To draw a vertex array, there are a few different functions, I believe 4. I will show actually the GL draw arrays from this. GL draw arrays. This is the easiest one, and it's waiting 3 parameters. First of all, what kind of primitives do you want to draw? This is the same as you would pass in GL begin. So you can use triangles, you can use quads, or anything you would pass into GL begin. I will draw triangles. So GL triangles. Okay, the next parameter is actually the starting point of the vertex which you want to draw. I want to start from the 0th vertex, so I pass 0 into here. If you would have for example 4 vertex right in here, but you will just start from the second, then you just pass 1 into here, because then we don't draw the third vertex. And the last is actually the number of vertices you want to draw. I have 3 vertices, so I will just pass 3 into here. And that's all it needs to be done in order to it to work. You don't really need this gly header file, although I have included in every project of mine from now on, because vertex arrays were relatively because vertex arrays are relatively old. It was introduced in OpenGL 1.1, so it should work without a problem. Okay, so while I'm talking, this is compiling, and let me try to run it. And yes, indeed, we get the exact same result we had earlier, except that I have used vertex arrays. There are a little bit so it has a little bit better performance than doing immediate mode, so it's GL begin and GL end kind of thing, because you don't have to call that many of GL vertex and GL color function, but instead you can send the entire array to the video card at once. It's not much, although, because it still store your vertex data in your RAM, so in your random access memory, so you still have to send this data to the video card from the memory, and you send the same amount of data, so it's not that big of a difference. So let me show you the interleaved array. This is interleaved array. Now you can create another array and call it, for example, color, and here you can store the color, and then the similar way you set the color pointer, except that you pass color into here instead of f. So this is obvious. You just use the GL color pointer function, iterating the exact same data as the GL vertex pointer, so the exact same parameters. So there is nothing too hard in that, so that's why I will do interleaved array. So basically use one array to store everything. For example, store the color. Let me make the first vertex to red, so I use 1, 0, 0. The second vertex to blue, so I use 0, 1, 0. And the third vertex, let me make it to green. So RGB, actually, this was the green, the second was the green, and this is the blue. Okay, so here we go. I just passed into the color value into the same array where we have the vertex value. And this is a little bit trickier one, and we have to use this stride value right here. So this stride value is basically the number of bytes between two vertices. You can see that we have 6 floating point variable between two vertices. Actually, there is a... yeah. Okay, so... yeah, so there is 6 floating point variable between vertices, so I just write 6 times the size of the float. So this is it, and the second function which we have to call in order to work is GL color pointer. As I said, it has the exact same parameters, except now we don't pass the starting point of the array, but we start from here, which is actually the 0, 1, 2 third element. So that we get the address of the third element in the array. So it will pointing into this 1, which is immediately the color. And if everything goes correctly, which I cannot guarantee, this should work. And by the way, I've had the same amount of stride in here as well as into the vertex. Okay, it did not. Of course, I forget to enable the color array. As I said, we have to enable everything we use. So GL enable client state and GL color array. And here I will disable it as well. So GL disable client state and GL color array. That's right. So now it's everything. Oops, I mistyped it, isn't it? Yep, I did. So disable client state. And now if I compile it and run it, it should produce a colored triangle, and indeed it does. A colored triangle. That was it. Obviously, the other parameters like texture coordinate, you can do basically the same basic idea. So let me show you another feature, the GL draw elements. The difference between GL draw arrays and GL draw elements is that the GL draw elements, actually let me write it here, GL draw elements. So first parameter is, as in same as GL draw arrays, is the type which you want to draw. This is GL triangles again. Next is the number of elements you want to draw. This is 3. We want to draw 3 vertices. Okay, and the next parameter is actually the type of an index array. So let me create an index array. Create it right here, and this will be an unsigned integer, and I just call it index. Okay, and this will be an array which contains the index which order you want to render. So first of all, I want to render the first vertex, then second, and then the third vertex. So this is just as simple as that. Obviously, in case of a bigger object, like in case of a cube, for example, you have 8 vertices, but you use the index array a lot. So basically, you refer the same vertices. So 0 refers that this is the third vertex, 1 that this is the second, and so on. So if everything goes correctly, then it should draw the same things. So the next is the type of this array, which is GL unsigned int. Okay, and the last is actually a pointer to this array, which is the address of index. That's as simple as that, and if I run it, I should get the same result. Although I already have somewhere variable name index, so I can call it something else, like ind. And here as well, when I pass it the address ind, because it said that I've already have such a thing. As you can see, redeclaration with a new type. But now, if I compile it and run it, we should get the exact same result as we had previously, as you can see. Why is GL draw element is better than GL draw array is simple. Basically, I said with the cube example. For example, to draw a cube by using triangles, you would need to use 36 GL vertex 3f function call, or 36 element into this array. And obviously you have only 4 vertices in case of a cube. So, but you will send 36 calls to vertices if you just use the GL draw arrays function. But with GL draw elements, you just have defined the 8 vertex right here in the vertex array, and you define the indices. And in this case, your video card could cache the vertices, so it will basically store it in the video card. So it gives a slightly better performance, not by much, but something to start with. Right, okay, let me just write back to GL draw arrays. So GL draw arrays. For example, in case of the object loader, we could use this, because object loader is working exactly like this. The OBJ loader which we wrote. It stores the indices, and it stores another in a vector the vertexes. Okay, so let me write back 0, 3 the parameter. Okay, and let me delete this indices array. Now it's time to move on something that more recent, because it is already, although I show you, it's already outdated. It's depraised at OpenGL 3.1. Basically in OpenGL 3.1, the only way you can send data to the video card is by using vertex buffer object. And let me create one of these vertex buffer objects. It's very similar to create it like you would create a texture. The difference, by the way, the vertex buffer object. So a buffer object is basically a memory space which is stored in your video card, and that's obviously increase the performance by much, because you don't have to send data in the slow buses when you have already the data in the video card. So that is why we should always use vertex buffer object, although I will not always use vertex buffer object, but you get the point. So this is basically the only way to send data in the modern OpenGL. To use vertex buffer objects, you need an identifier for the vertex buffer object, similarly as you had needed identifier for the texture. So let me create that. I will call VBO whatever. So this is the vertex buffer object. This is okay, and there are several kind of buffer objects, but I will talk about vertex buffer objects obviously. So to create a vertex buffer object, you use the glgen buffers function. This glgen buffers function will basically not generate a buffer, but actually generate an identifier for the buffer. This is the same as the GL generate textures, and it's exactly with the same parameter. How many vertex buffer objects do I need? I need one buffer object, and pointer to where it should generate the ID VBO. This is the variable I just created up here. So now I have created an identifier. Similarly, as in case of textures, now I need to bind it. So gl bind buffer, and then this first parameter is basically the target, similarly as in textures. Although unlike textures, it doesn't wait gl texture 2D or something like that, but it's waiting what kind of object, what kind of VBO is that. I will create a gl array buffer. This is basically stands for that this is an array buffer. So vertex buffer object basically. You can store other things in buffer object, but I will not go into that. Okay, and I bind the VBO. Okay, at the first time when you bind vertex buffer object, then it will immediately initialize it. So it although this was just an ID, but with GL bind buffer we actually created a buffer object. Now we have to fill up this buffer object with data. To fill up a buffer object with data, we use the function GL buffer data. This is the name of the function which will send data to this buffer object. So the first parameter is again the target, which is GL array buffer. I will talk one more kind of buffer type in this tutorial, basically the same as the index. Okay, then the second is actually the size of what is the size which you want to assign here. And actually here I will use this float array which I had here, because vertex buffer object is basically a vertex array which is stored in your video card. So this the initialization and everything will be very similar. So I use the size of f, which is basically the size of this array. This is how many bytes should that vertex buffer object be. Okay, the next is actually the data which you want to assign. I want to assign the f, so it's a pointer to the data. If you pass null into here, that pretty much means you don't want to assign data, you just reserve a space, and later on you will assign data with calls like gl buffer sub data. Okay, and the last parameter is actually the flag or a mode how it should store the data. I will use the gl static draw. There are kind of few of these, actually exactly 9 of these flags which you can pass in here, and the flags will look like this: gl a underscore b. Okay, where the a could be a stream or static or dynamic, and b could be any of the following: draw, read, or copy. These are basically the static mean that you don't want to change the data. The dynamic mean you may want to change in every frame, and the stream mean you want to change sometimes the data in the vertex buffer. The draw mean you will use it directly to draw the data. The read mean you will read the data but you don't directly draw, and the copy mean I don't know what does it mean, it's copy the data, I guess. So this is what you can pass in here, and this is obviously 9 kind of this different combination. Okay, so now you have filled up this buffer object, so now we can actually draw it. The display is pretty similar as we had previously, because as I said, the vertex buffer object is basically just a vertex array in your video card. So you one important difference is that instead that first of all you have to bind this buffer. To bind the buffer we use the same thing as we bind it earlier. So gl bind buffer to bind a buffer. You have to do that in order to that the OpenGL will know what kind of buffer, from what kind of buffer do you want to draw. The second difference is actually that in here, in the last parameter of the GL vertex pointer, you don't pass a pointer to an array, but you pass offset basically from the beginning of the vertex object in bytes. So in that case I pass 0 in here because my vertex data starts from 0. And here, actually this is a void pointer by the way, this last parameter, and here I should pass 3 in here, but 3 times size of float in here, but I just cannot pass 3 times size of float in here, but I have to convert it to a void pointer. So I will just use casting void pointer and 3 times size of and float, because we start from the third element of the vertex buffer, so from the third element. So this is the color of the third element. And yeah, if I am correct, this is all what needs to be done. And actually to unbind the buffer basically, because now it is binded, just bind a 0 value in here, and that pretty much means you don't want to use the buffer anymore. Let's try to compile it and see what happens. In 77 I have a missing closing bracket. Let's try to compile it again, and if everything works correctly we get exactly the same result, except that now this array is stored in the buffer, in the video card, in a vertex buffer object. So let me show you some other function which you can use. For example, the gl buffer sub data, gl buffer sub data, and this function can change the part of a buffer. For example, if I want to change the first coordinate of the vertex, then I just use the first of all the target, gl array buffer, as always. Second, the offset, which will be 0 in this case because I want to change these 4 coordinates right here. Then the next is the size which I want to replace. This is 3 times the size of float. And the third, last parameter, the fourth parameter, is actually an array, a pointer to an array, which I want to change this first 3 floating point numbers. So let me create one of these. So float and replace, and this should contain, for example, let's contain it 0 and 10 and -4. So with all I do is actually actually will change the 0 to -4 value in the vertex buffer to 0, 10, -4, so it will be a very high triangle if everything goes correctly. So replace, and that's all, because I use the replace array. And let me try to compile it and check to see if it works. So now we should get, yep, a really high triangle indeed. So this is how the GL buffer subdata work. I will leave to you that GL map buffer function, because that's not too complicated. You just map the buffer. So GL map buffer, this is the name of the function, GL map buffer, and it's waiting for the target and flag, so it can read or it can write, or it can read or write basically. And then after you finish, and it will give back a pointer to a void pointer, which is point basically here at the same array. And then you use the GL unmap buffer to send back the data to the video card. So that's all about mapping, and that's pretty much it about vertex buffer objects. So first of all, let me just summarize what I just said. So first of all, the buffer object is basically just a memory space in your video card where you can store a lot of kind of data, for example an array. And then you create one of these buffer objects by using the GL buffers, which is waiting how many buffers should it generate and where to the so the pointer to where it should put the index there. Then you bind the buffer and you fill up with data with GL buffer data. Okay, you can additionally call GL buffer subdata and GL map buffers to later on replace part of this data. This is what makes it better than, for example, a display list, because in case of a display list can actually store in your video card, but a display list cannot be changed. So a lot of things, like for example, if you want to do skeleton animation and GPU binding, you can do that simple with display list, because you cannot change the part of the display, any part of the display list. That is what makes it better. Okay, which it makes it better from immediate mode and vertex array is that it's quicker, because obviously it is in the video card. Okay, in the display function I have to use almost the same thing as if I would use a vertex array, except that I first have to bind bind this vertex buffer object. Then I enable everything I want, so GL vertex array, GL color array, so on. Then I call the function GL vertex pointer and GL color pointer, GL texture coordinate, text core pointer, and so on, GL normal pointer for example. And then I can use the GL draw arrays or GL draw elements. That's what I didn't show, did I? By the way, you can, if this is dynamically allocated, you can free it, so you don't need it after you call this GL buffer data. You don't anymore need this array right here. So if it is dynamically allocated, you can free it after the GL buffer data call, because it will be stored in the video card, not in your RAM. Okay, so the thing I wanted to show you is generate another buffer object. So let me call it IND, like index, similarly as we did previously, and GL gen buffer I generate one buffer to the IND, so the index. And similarly I can fill up this index, but I will use the GL element array buffer. So right here I will use the GL bind buffer, GL element array buffer. This is basically the name if you want to use an indexing element. So you don't want to use an vertex array, but you want to use an index for the vertex array, and just bind the IND here. Okay, and similarly I can fill this up with the GL buffer data. So GL buffer data, GL element array buffer, that's right. And let me create an indexing array, so unsigned integer, I don't know, IND array, and just again use the 0, 1, 2 right here, and just pass it into here. So GL element array buffer, IND array, and here similarly IND array. That was simple enough. So actually we can just delete this, we don't really need that. And in the display we just bind the buffer. So GL bind buffer, GL element array buffer, and use the IND, which we have created up here with GL gen buffers. Okay, so I binded the element array buffer, so basically the indexes, and then I need to call the GL draw elements. these GL row elements, we're waiting the same parameters as before. So the second is the number, so we want to use 3. The second is the type, so GL unsigned integer, and the last is the offset, similarly as here, so just pass 0 in here or null, and this will basically the offset, and then I unbind the buffer just to avoid weird behavior after this function call. So GL bind buffer, and if you bind 0 to any buffer, it will basically mean that you don't want to use any buffer there. So element GL element array buffer, so GL element array buffer, and just pass 0 into here. Element. That's right. Almost right. Now it's right. And if we run this program, ind array. Okay, let me go back. Of course, I forgot that this is an array. So like that, it's an array. Now it should work. So I compiled it and I can run it right now. And as you can see, we get the exact same result as we had earlier. So this is basically how the vertex buffer object work. And let me show you, because this GL vertex pointer and GL color pointer, GL normal pointer, so on calls get a bit outdated. There is another call which is GL vertex attrib pointer. This is don't be fooled. This is basically the same thing as GL vertex pointer, except that we get target from the shader which we are using. Currently I'm not using shaders right in here, but because this vertex buffer object is the most recent way to do it, I thought I might just include it right here into this tutorial. And I include here the actual last way of doing vertex array buffers as well, which is the newest way of basically doing it, because even the GL normal array and GL normal pointer, GL vertex pointer, GL color pointer, these functions have been depraised and removed by the OpenGL version 3.1, and there is a new way of doing things. It's basically, don't be fooled, the same way, just different function names. And you can only use it if you are using currently shaders. You can't use it in any way else. So I just copied these buffers into my shader tutorial file, so I can show you. Let me just open the vertex shader and the fragment shader as well. Okay, here I go, and let me create a few variables, like creating a varying. Here is the top varying and vector 3, and this will be actually, yeah, vertex 3 will be okay, and this will be vertex pos or something. Okay, and this vertex position, we will not use the GL vertex built-in variable, but we will use this vertex position. Now we have to associate somehow the vertex buffer objects and this vertex position. To do that, I have to use the GL get attribute location, like I did here. Actually, I can get it here. So vertex pos. Right? Yeah, vertex position. So now this index variable right here will contain the position of this attribute variable if you know shaders. Of course, if you don't use shaders, probably you can leave, because all other part of this tutorial is finished. Just with the shader part, the newest way of doing things is not finished yet. So here I will bind the buffers. This will remain the same, and creating the buffer remain exactly the same. But what will not remain the same is this GL enable client state. I believe this function was depraised as well. Instead, we will use the GL enable vertex array pointer. This is the new name of the function, and oops, sorry, this is vertex attrib pointer. As you can see, here is the attrib. So attrib pointer, here is the attribute, and this is waiting for the index which we get with the vertex position. So I just pass an index right here. So now I have enabled a vertex attribute pointer, and this is called index. Let me enable another one. So let me just copy this into here, and this will be, I don't know, color, for example, color. And let me get the color pointer as well. So int and color, and this is equal to GL get attrib location. And first of all the program, and then the name, which is color in this case. So color, and that's it. So I pass the color, and again I have to disable it after I use it, and I do the same. So disabling right here, except I use disable instead of an enable. So disable, and here as well disable. Oh no, that's another function. Okay, so I disabled and enabled these. Okay, and instead of GL vertex pointer and GL color pointer, I will use the function called GL vertex attrib pointer. So GL vertex attrib pointer. This is the name of the function, and it has quite a lot of parameter. I will copy it here. So as you can see, the header or function definition of it here. This is GL vertex attrib pointer, and this is what we are trying to do. First of all, the index. So first of all, let's pass the index, which is in our case the vertexes. The second is the size. This is either 1, 2, 3 or 1, 2, 3 or 4. In this case 3, because our vertexes has 3 value. As you can see, we have a 3 value vertex. So this is basically the same parameter as we passed into the GL vertex pointer as well as the first parameter. Next is the type, which is again the same, GL float. Next is the normalized. I'm not sure I want to talk about it, just pass GL false, you don't want to normalize it. The next is the stride. This is again the same as we had in the GL vertex pointer, so just pass 6 times size of float. And the last is the pointer. Again, this is the offset in case of vertex buffer object. That's press 0 because we start from the beginning. Okay, and the next is again use the GL vertex attrib pointer, and now we will do it with the colors. So I just have color right here. All other values are the same except the last one, which is this, which we wrote in here. So as you can see, it does the exact same thing, just a little bit more complicated way. Okay, let me delete this GL vertex pointer and GL color pointer, and let me see if how the vertex shader handling this. So the color, color 2 should be the uniform variable, and the color is the varying variable, because we want to input to this color, because this is an attribute actually. Why I write attribute? I don't know. I'm a little tired. Attribute. This should be attribute variable because we want to get data to it in every frame. So this is attribute variable, and the color 2 should be varying variable because we want to send it to the fragment shader, and this attribute is not needed actually in here. And instead of using GL vertex, I will use the vertex pos. So vertex position. Okay, and in the fragment shader, actually, GL color 2, yeah, about right. Varying, it's actually wrote with A. Okay, I think we are ready to try to compile it. So I am in the right folder. I'm not guaranteed that this will compile. I'm not used to do too much of this. GL enable vertex attrib pointer. Did I mistype that? Of course I did. This is array, not pointer. This is GL vertex array. The pointer is the vertex attrib pointer. This is array. And here as well. Sorry about this. Array. Okay, and now if I compile it, and of course in case of disable, this is array as well. So array, and here as well, array. Now if I compile it and run it, then I get a problem actually here in the vertex shader. That's because I try to multiply with a vector 3 instead of a vector 4. So let me just convert this to a vector 4 with the constructor, as you saw it in the data types tutorial. So by just passing the w equals to 1.0, and then if I run it, ATR was not declared because we passed the color. Right, so now if I run it, and as you can see, we get the same triangle as previously, and that is the most recent way to set data. So again, just to make sure that I told you everything, let me quickly go through the program again. So just the new part. So we use the GL enable vertex attrib array instead of the GL enable client state. This is basically does the same thing, just a new name, so don't be fooled about this. GL vertex attrib pointer is replacing the GL color pointer, GL normal pointer, GL vertex pointer, so on, these calls, with this one single call, and of course this waiting for what do you want to change. And in the vertex, you create attribute variable for everything you want to pass into the shader. So the vertex position, the colors, and so on, all of these. And you get the location of this. So here we get the attribute location, and that will be the identifier which we are going to use. So for here as in the enable, and here is the pointer, we use this index to describe what do we want to change. So where should we want to add this data. Okay, and here this part of the code has no depraise functionality at all. So it's all able to compile in OpenGL 4.2 as well without depraise functionality. Of course, this GL model view projection matrix is actually not So this actually is depraised, and we should use a uniform variable to give this matrix to the shader, and this GL position built-in variable is actually depraised as well, so we should use an output variable to output in here, from here, if you want to use something like GLSL 4.2 and OpenGL 4.2. Okay, and that was it, and I hope you enjoyed it, although I showed you a lot of new function and you have to learn it if you want to use this kind of vertex buffer objects. And thank you for watching, and have a great